All right, let's take a look at our double angle identities. Now that we've seen that we can build them a little bit off of our adding, our addition identities. So here they are. Here are the double angle identities that we are going to work or to look at. So cosine of 2a, cosine of 2a, an angle's double of an angle can be written three ways. And we're going to pick whichever way we need. To find the sine of 2a, we're going to do 2 sine a cosine a. Here's how we can find the tangent of twice an angle. We can also find the tangent of twice an angle by using this formula. We can say tangent of 2a is, of course, the sine of 2a over the cosine of 2a, depending on what you've got. If you know tangent or if you know sine and cosine, we can make that happen. I would like to remind you, very important, if we have a trig function, no, let's try, the writing out didn't work. If we are given a trig function, in general, my trig function, if f is a function, the trig function of 2a does not equal twice the function of a. You can't take the 2 out. You've got to find the sine, cosine, or tangent of 2a as a whole. You can't do the sine or cosine or tangent of a and then double it. It doesn't work that way. We've got to use our double angle identities. Let's find our function values of 2 theta given the information below. Alrighty, so we are told that the cosine of theta is 2/3. And we know the sine of the same angle is less than 0. Let's find the sine of 2 theta, the sine of cosine of 2 theta, and the tangent of 2 theta. So what we want to do first, to find I can do the cosine of 2 theta real easy because that's just given to me. But let's start with the sine. I just like to start with sine. So if we want to find 2 theta, we want to find the sine of 2 theta, we need to know the sine of theta. Well, how are we going to do that? Well, there's a couple ways. We know cosine is adjacent over hypotenuse, and then I can work that out and find opposite over hypotenuse. We could do that. But what I am going to do is I'm going to say, alrighty, I know what cosine is, so I am going to use one of my identities because that's what this unit is about. Let's use our identities. So the sine squared of theta plus the cosine squared of theta we know equals 1. Well, we know what cosine is, so I can take out cosine squared and plug in a 2/3, which I will square, and that's going to equal 1. So sine squared of theta plus 4/9 equals 1. So coming up here, we know the sine squared theta equals 1 minus 4/9. So sine squared theta equals 9/9 minus 4/9. That's going to be 5/9. Square root both sides. So the sine of theta is going to be the square root of 5 over 3. Now we want sine to be less than 0, which means we need to make that negative, make that one negative because sine is less than 0. Now the problem didn't ask me to find sine of theta. It asked me to find sine of 2 theta. So when we look back at our angle identities, our double angle identities, we know the sine of 2a equals 2 times the sine of a cosine a. So the sine of 2 theta is going to be 2 times the sine, 2 times sine theta, cosine theta, Well, what's cool is I know cosine theta. Cosine theta is 2 over 3. Sine theta is negative 5 over 3. So we're just going to plug those in. So we're going to do 2 times negative radical 5 over 3 times the cosine of theta, which we said was 2 over 3. So so we're going to do 2 times negative radical 5 times 2. That's going to give me negative 4 radical 5. Say one thing and write another thing. That's how we get in trouble. Radical 5 over 9. So there is the sine of 2 theta. Boom. They also wanted cosine of 2 theta. So I'm going to give myself a little more room. One of the things they asked us to find was cosine 2 theta. I'm going to switch colors so we can keep our work straight. Well, we were told that one of our functions for cosine 2 theta, it just uses cosine. So I don't have to use sine again, is I'm going to say 2 times cosine squared theta minus 1. There's my identity. Because I already know cosine. So I can say 2 times 2/3 squared minus 1. So that's going to give me 2 times 4/9 minus 1. So 8/9 minus 1. 8/9 minus 9/9 gives me negative 1/9. And then the last one they wanted us to find was tangent of 2 theta. Well, I already know sine 2 theta and I know cosine 2 theta, so I'm just going to plug it into sine 2 theta over cosine 2 theta. And I'm using this one because I don't know what tangent of theta is, but I do know sine 2 theta and cosine 2 theta. So sine is going to be negative 4 radical 5 over 9. Dividing with fractions means multiply by the reciprocal. So I am going to multiply by the reciprocal. The 9s are going to cross out or cancel out. A negative times a negative is a positive. So the tangent of 2 theta equals negative 4 radical 5. So that's how we can find some quick and easy double angles when we are given something else. And that's not the only way. You could have done some of the other things that we know, but I just like that way the best, because once I know sine and cosine, I could have just found tangent by doing sine over cosine. We did get the exact same answers. In my notes that I wrote for myself, I actually did it differently here in the video than I actually did on the paper. So just to let you know, if you're like, well, would this way work? If you're doing the right things, you're using the right formulas, then yes, multiple things work. All right, so if you have any questions, please let me know. In the next video, we're going to do example number 2.